Welcome, scholars, to Lesson 3.3, Equations of Perpendicular Lines. So we've already talked about parallel lines and how the slope of parallel lines are the same, and that's why they'll never intersect. With perpendicular lines, they do intersect, and when they intersect, they form 90-degree angles. So their slopes also have a special relationship, but instead of being the same, let's fill this out. In a coordinate plane, two non-vertical lines are perpendicular only, or if and only if the product of their slopes is -1. So what does that mean? That means their slopes must be reciprocals and opposites. So again, for them to have a product of -1, that means they have to be reciprocals because reciprocals multiply to 1. And then it has to be opposite, negative and positive, because you want it to multiply to -1. So just as an example, a reciprocal of, let's say, 2/3. The reciprocal of 2/3, we just flip the numerator and denominator, so that becomes 3/2. So those are reciprocals. And then the opposite of, let's say, 4 would be -4. So as long as we make them reciprocal and opposite, then we should be good to go. So let's look at example number 1. What is the slope of a line perpendicular to the line whose equation is y equals -2x plus 6? So first we have to identify the slope of this equation. And just to remind you, slope-intercept form is y equals mx plus b, where m, or my coefficient, the number in front of the x, is the slope. So of this equation, our slope is -2. So we need the reciprocal and the opposite of -2. So let's start with the reciprocal. So let's just write -2 as a fraction. So -2/1. That is going to flip to become 1/2. And that negative becomes positive, so my slope is just positive 1/2. All right, so for example number 2, just like with our last lesson, we have to do some manipulating so that we can make this equation into slope-intercept form so we can do the same thing. So it says, what is the slope of a line perpendicular to the line whose equation is 2x plus 5y equals 20? So I'm going to first rewrite it into slope-intercept form. So 2x plus 5y equals 20. I'm going to go ahead and subtract 2x from both sides, because again, I want y by itself on the left and everything else on the right. So that leaves me with 5y equals, I'm going to go ahead and put the x in front so it looks a little bit closer to my y-intercept form, or my slope-intercept form. So -2x plus 20. And I explained, how I can kind of rearrange, because if I'm adding, I can rearrange and it's still the same thing. I explained that in the last video. So now I'm going to divide both sides by 5. And I get y is equal to, and then this is -2/5 x, and 20 divided by 5 is 4. So now that my equation is in slope-intercept form, I'm going to take the opposite and the reciprocal. So -2/5, let's start with the reciprocal. That becomes 5/2, and then negative becomes positive. So it's just 5/2, or 2.5. So that is my slope. So now, just like with the last lesson, we are going to make the equation. So first part is find the slope. Then we're going to find the equation that passes through a particular point. So first, let's write the equation, the original one. Y equals -1/5 x plus 2. So then I'm going to identify what my slope is going to be. Again, the opposite and the reciprocal. So negative 1/5 becomes just 5 over 1, which we're going to just write as 5. Positive 5 over 1, which we're going to write as 5. So we're going to put that into our slope-intercept form. 5 is my M, and I still have to find what B is. And that's where my point comes in, this point right here. 1, 3 is going to be placed into this equation so I can find what B is. Because if I have 3 variables, I don't know what to do from there. But if I can substitute 2 numbers into these 2 variables, then I can solve for the third one. So I'm going to go ahead and put 3 in for Y and 1 in for X. And see how this allows me to solve for B. So 5 times 1 is 5. And then when I subtract 5 from both sides, 3 minus 5 is negative 2. So my slope is 5. My y-intercept is negative 2. So my full equation is y equals 5x minus 2. And I am done. So now with example number 4, we're going to do the same thing, except we have to rework this so it is in slope-intercept form. So x plus 3y equals 24. We're going to go ahead and subtract x from both sides. So I get 3y equals negative x plus 24. I'm going to go ahead and divide. Here, let's put our line. I'm going to go ahead and divide by 3. Again, these are the same steps as before, so if I'm going a little fast, don't worry, you can always pause, rewind, also raise your hand and ask me to clarify. But I'm going to go ahead and just rework this so it's y on the left, everything else on the right, so I can easily identify my slope. So when I divide just an x divided by 3, that is 1/3 x. So negative x divided by 3 is negative 1/3 x, right? I'll put this to the side here. If I'm dividing x by 2, that's 1/2 x. If I'm dividing x by 3, that's 1/3 x. If I'm dividing x by 4, that's 1/4 x. And so on and so forth. So that's how I get this 1/3 right here. So negative 1/3 x, and then 24 divided by 3 is 8. So now I have my original slope, but I have to make it the opposite and reciprocal. So negative 1/3, these are all going from negative to positive, but remember, you just flip it. So flip the 1/3 to 3 over 1, and then you just always change the sign. So negative is now positive 3. So I actually, hopefully, yep, I have some more room. I'm going to go ahead and put that 3 into my slope-intercept form. So now I can use this point so I can create my whole equation. So I'm going to put in negative 3 for y, negative 2 for x, and that allows me to solve for b. So negative 3 is equal to 3 times negative 2 is negative 6 plus b. Add 6 to both sides. Negative 3 plus 6 is just positive 3. So b is 3. So slope was positive 3. Y-intercept was positive 3. So my equation is y equals 3x plus b. Now these steps are the exact same as before, but just as a recap. Actually, I'm going to erase this and then write the steps. And I know I'm doing it after I did the problem, but it's okay. You can just write them down. Use these steps, use these notes as you do the practice problems. But step 1 is to, identify slope, Identify perpendicular slope. That's what we did first. by, after I reworked it and just, maneuvered it so that it's y equals, so it's in slope-intercept form. I then identified my perpendicular slope. I said -1/3 has to be the opposite reciprocal, so it's +3. So that's what I found first. Then I have to write my slope-intercept form with the slope, with the new slope, with my new slope. So I wrote y equals 3x plus b, right? My intercept form with new slope. Then I have to substitute the point it gives me for x and y. And I put in -2 for x, -3 for y, to solve for b, in order to solve for b. And then once I have b, I'm going to place m and b into y equals mx plus b. Then I have my equation. So that is the end of this lesson. Go ahead. Oh, no, it's not. Just kidding. We actually have one more example. I'm so sorry. Example number 5. The lines represented by the equations 6y minus 3x equals 30 and y minus 2x equals -2 are blank. So the reason why I'm including this in this lesson is because we have already done parallel. Now we've done perpendicular. Now our last thing is just to figure out the relationship between our two equations, our two lines. Are they parallel? Are they perpendicular? Are they the same line, or are they none of the above? So let's go ahead and rework these. So 6y minus 3x equals 30. Let's go ahead and add 3x. That gives us 6y is equal to 3x plus 30. And let's divide by 6. All right. So if I'm going too fast, just pause. So 3 divided by 6 reduces to 1/2. So that's 1/2 x. And 3 divided by 6 is +5. All right, and then let's go ahead and rework this one. Y minus 2x equals -2. So let's add 2x and cancel those out. So y is equal to 2x minus 2. All right, so are they the same line? No. Do they have the same slope and different y-intercept? No, they're not the same or parallel. Are they perpendicular? Are they opposite and reciprocal? So I have 1/2 and I have 2. Those are reciprocals, but they are not opposites unless I did something wrong. No, this one is positive, and then when I move this over, yep, this one's positive. So yeah, those are, if one of them was negative, that would be perpendicular, but they are just opposite, just reciprocal, not opposite. So therefore, they're not perpendicular. So that means they're neither. So they are neither parallel nor perpendicular. And again, because these slopes have no relationship. Slopes are not the same, nor are they opposite and reciprocal. So they are nothing. So now I'm pretty sure that is the end. Yes, it is. That's actually the end of our whole unit too. So go ahead and work on the practice, work on the mastery check. Then when you are done, you can work on the practice test and then actually go ahead and take the unit test. Again, let me know if you have any questions, and good luck.